So we say 4. Well, let's prove it. How can I get rid of the A term? X equals -1. Therefore, 4 times -1 minus 3 is equal to B. 4 times -1 is -4. So B is equal to -7. That's what I had, wasn't it? Yeah. How do you then find A? You tell me how you find A. -7 back into what?
Okay, put it back into the equation as a x.
Left equals 0. Write it. 4 times 0 minus 3 is equal to I times 0 plus 7. 0 is don't work, does it? A is gone. We don't want A gone. We want B gone. Sorry? 0. Yes, 0 plus 1. Right? Got it right now? -7. So 4 times, so that's -3 is equal to I minus 7. Therefore, I is equal to 4. Oh, we're back to we start now. Are we able to do that? So, dealing with this side, yeah, we let u equals x plus 1, du by dx is equal to 1 dx is equal to du. Yeah. Then we rewrite the integral. So we say 4 over x plus 1 is equal to 4 over u. And that's dx. And in this one, I'm trying to show now the point of that bit. We want to write dx as du, because that's got to be with respect to that variable. So that's the reason you do that. Yeah. And then we know we can take 4 outside, natural log, and we just replace u and plus c. So that's that side dealt with, and I think you all got that quite ably, that if we got that fraction like that, it's going to end up with a ln function, constant's going to come in front, and we put the whatever we call u inside the brackets of the log function and add a constant. So that's fairly standard. But over this side, we've got the integral of 7 over x plus 1 squared. Again, we'll let u equal x plus 1. And we have done these before, but it's a few weeks ago now, okay, when we've done substitution. So then we can write that integral. Then we can differentiate du by dx is equal to 1. Dx is equal to du. So nothing different so far. But now we write this integral of 7 over x plus 1 squared dx is equal to the integral of 7 over u squared du. Yeah? So we can bring a constant outside, 1 over u squared du. Now this is where the laws of indices come in. We can write this as 7 times the integral of u to the minus 2 du. We've now got a function that is an ix to the n problem, where we know that the integral of that is ix to the n plus 1 over n plus 1. So we add 1 to the index and divide by the new index to integrate it. So what we end up with is 7 times sorry, u to the minus 1 over minus 1, which changes that 7 into a minus 7. Yep. Plus c. Okay. We can write that as minus 7 over u plus c. So we put it back down the bottom and made the minus 1 index to plus 1. And lastly, we replace u with what we called u in the first place. X plus 1, all plus a constant of integration. So bringing the two things back together, it is 4 over the first, 4 over minus 7 over. So we got to do the whole thing as 4 ln x plus 1, and then that's minus minus 7, so that must make a plus 7 over x plus 1 plus c. Here's your final answer. If anyone got that without any help, they've done well. Alright? So that only ends up as a log. If you get into your brain too much about these always ending up as a log function, multiplied by the constant, and then you get that situation in there, and you don't go through the process of doing the integration by substitution as a step-by-step process, you could well come unstuck. Because a lot of people heading towards that being a log of x plus 1 squared, and it isn't. It's only when I run over a single variable you end up with a log function. Just be careful of that, alright? Any questions before we wrap up? This afternoon,